Alright, this time we have proportion and variation that we're working with. So for number 1, let's say for a specific children's liquid medicine, you give 5 milliliters for every 25 pounds. How much should you give a child who weighs 60 pounds? So just like before with other math topics, there are several different ways you could do this. One way to set this up is to have the 5 milliliters over the 25 pounds, and we'll abbreviate pounds here as LBS, is equal to, and then we don't know how many milliliters yet we need for the 60-pound child, over the 60 pounds. So we put X in for the milliliters and the 60 pounds below it. So you'll notice here that our units are matched up. We have milliliters on the top of both fractions, pounds on the bottom of both. So make sure whenever you're setting up your proportions that you do have your units matching up. Otherwise you may get a different answer depending on how you have it set up. So next we can cross multiply like we've done before. We can go through and do our 60 times 5 to get 300. Is equal to 25x, and then we can divide both sides by 25 to finish getting the x by itself. And then if we do the 300 divided by 25, we get 12 milliliters for our x. For the next one, we have to calculate your BMI. We have that the BMI varies directly with your weight in pounds and inversely with the square of your weight in inches. So our keywords here are directly and inversely. So this means we're dealing with a constant of variation. So in this case, we'll have B as our BMI is equal to K, our constant of variation, times, in this case, the weight, because the weight varies directly with the BMI, over, and then we have that the height varies inversely with the BMI. And not only is it just the height, it is the square of the height. So we're going to have h squared in the denominator here. So h for height, w for weight here. Once we have that set up, we can move on to the next part of our sentence. We have, if you weigh 140 pounds and are 65 inches tall, your BMI is approximately 23.29. So we can use the information in that sentence here to go through and solve for our K next. So we have 23.29 is equal to our K times the 140 divided by the height, which was 65 inches, squared. And if we do the 65 inches squared, we get 4,225. And then we can multiply both sides by that denominator, 4,225, all in one step to help save us a little bit of room here and help eliminate an extra step. If you want to write them out in separate steps, you certainly can. So once we multiply on the left-hand side, we get about 98,400.25 is equal to, and then we can use that commutative property we used before to switch the order of the K and our value of 140 around to get 140K to make it look more like the formulas we normally use. And then to finish solving for our K, our constant of variation here, we can divide both sides by 140. And here in this case, if you look back up again at the problem, I said round your constant variation K to the nearest whole number. So once you divide it here, we want to round to the nearest whole number, which should be 703. That's what we would round k to. And then the next part, your friend weighs 160 pounds and is 69 inches tall. What is your friend's BMI? So here, once again, B is for our BMI. So we have B is equal to, we want to plug in the K that we just had into that equation that we set up to begin with. That B equals K times W over H squared. So we have that K of 703 times the weight in this case, which was 160 pounds, divided by the height of that person, which was 69 inches. And we'd have that squared. So here we get approximately 23.63 if you go through and calculate the BMI there. And make sure for both of these problems and any word problem to double check, make sure that your answer does make sense in the context of the problem. If you have questions on any of this stuff, make sure that you are asking.